Oh my God. Thank you, everyone. So let's be on time with the schedule. And I have the honor of introducing Ana Del Moral and Kelly Nunez Ocasio to talk about the weather in Africa.
Yeah, so I think that everybody's in the poster session right now. So thank you for those who are here and online, of course. So yeah, good afternoon. My name is Ana del Moral. I'm a postdoc at the Earth Observing Laboratory here at NCAR. And I'm co-leading this session with Kelly Nunez Ocasio from MCube, also here at NCAR, and Samson Hagos from the PNNL. So yeah, my slides are also compound, a work together of all the Africa Initiative collaborators within UCAR and also outside external collaborators on the weather topic. So probably it's not going to be as extensive as the climate one. So I took a little bit of time to explore the main research topics within this group based on the information that people were providing on our website. And as you can see, the main research topic is hydrology. Other main topics also include extreme weather events, lightning, wildfire, and precipitation, which probably gives us an idea of the weather challenges that also Africa is facing in this changing climate. Also, if we take a look at the expertise of the group, we can see a broad spectrum from remote sensing to observations, modeling, machine learning. And definitely it is exciting to see all this expertise in this group and to know that collaborations starting here in this Africa workshop and hopefully in the near future will enhance these projects and bring new impactful research for Africa. So as I mentioned, I will proceed now to showcase some different ongoing work on the researchers for this group, which hopefully leads to more collaboration. So first of all, we have the work led by Imoleayo Dode, sorry if I'm mispronouncing names here also, who visited Jimmy Duria from MCube from the Federal University of Technology in Akure, Nigeria. So this work is on the impacts of global warming on West African monsoon rainfall. And they work on a 20-kilometer grid WRF regional downscaling of 5 monsoon rainfall seasons for present and future scenarios. For the present initial and boundary conditions, they use ERA interim analysis. And for the future initial and boundary conditions, they use perturbations to represent the 2070s according to changes from CESM lens ensemble. So you can see here on the left panels, it shows the climate model on top. Sorry, I think that some of the letters are misplaced, but I think that you can get an idea of what it says there. So the panel top shows the climate model. The other three next ones are the 3 word physics combinations and the observations on the bottom. And the middle panels, they show the vertical panels in the middle, they show the percentage of rain differences for the future. And the right panels, they show the theoretical increases from just warming, raising moisture content at fixed relative humidity. So this basically gives an idea of physics sensitivity in the regional model. And I know that Jimmy is here and we'll welcome any questions that you may have in the discussion. So moving forward, we do have the presentation that is shared by Kelly Nunez Ocasio, who is also leading this moisture dependence of an African easterly wave within the West African monsoon system. They employed a novel model for prediction across scales, or MPAS model, applying a pseudo global warning method to a regional variable resolution configuration. And this allows for the simulation processed at convection permitting scales to address how moisture modulates the zonal mean state over Africa of this West African monsoon system. And this is applied to an African easterly wave. So The key points and the results is that more convection occurs in a moisture environment, but phasing of deep convection and the waves becomes suboptimal. That moisture can reduce the westward land wave translation and can indicate if convection over the Guinea highlands phase locks with the African easterly wave, and that more environmental moisture narrows and shifts the African easterly jet poleward, reducing the eddy kinematic energy available to the wave. So I know also that Kelly is here. So if you have further questions, again, I encourage you to ask them in the Q&A. So here we have also another project in the house. This is a slide shared by James Pinto from RAL, but this is a project also led by Joe Grimm, Anders Jensen, and Peter Lawrence from CISL. And it's the East Africa, Great Lakes, and Ethiopia project, or EAGLE for short. So this project, in summary, developed regional 3-kilometer climate data sets for East Africa via dynamical downscaling using WRF. It was optimized configuration for hydrology and agriculture planning, and it produced hourly model output for 3 decadal time slices. So present day with RCP 4.5, and then in the future into different frames in RCP 8.5. So here is one of the simulated present day annual mean precipitation maps that they produced. And actually, there's a website that I invite you all to check. I also put here the link to the website of the East African Great Lake Environment Project, and you can browse their products and also download that data set if you are interested. And of course, like reach out to them or to me afterwards, and I'll put you in contact with the project leads. Yep. Next, we have going more into final scale. We do have a project on nowcasting thunderstorms hazards over Lake Victoria. This is a project led by Rita Roberts and James Wilson. I see that Rita is also here in the audience today. So again, during the Q&A, you have the opportunity to ask questions for her. And I don't know who in the audience is familiar with Lake Victoria. Lake Victoria is one of the places in the world with most deep convection. And unfortunately, a lot of fatalities happen in the lake because of severe weather convection overnight. Mostly that is happening because of high waves produced by high-speed winds for these thunderstorms, and those waves capsize boats, especially for the fishing community on the lake, and that produces, unfortunately, fatalities. So in this loop that you see here, this is a radar loop, and for those who are not familiar, these are real-time observations of storms, and the colors mainly indicate intensity of precipitation. So what we're seeing here is a squall line storm moving from northeastern side of the lake and spraying during the night through the entire lake. But I want you to point to to have your focus on this area here, and you might see that there's this return, there's echoes on the surface of the lake, and this is actually the fetch of this storm producing this fetch over the lake of the wind speeds. So this was a storm of 5-hour duration that produced a 250-kilometer fetch with a 10-meter-second propagation speed. And why is this important? Because, as I mentioned, one of the fatalities come from wave heights, and wave heights are affected by wind speed, wind duration, and of course the fetch, which is the distance over the water that the wind blows in a single direction. So they've been analyzing several cases of squall lines and other severe storms that produce this fetch with observations. This is observation from a radar in Tanzania, and it's actually unique data that we have available right now. Well, especially Tanzania has available this data. And the main results are the bigger waves result from conditions that cause strong winds to blow for a sustained period over a large expanse of water. But if wind speed is low, only small waves result regardless of wind duration or fetch. So I know that this is an ongoing research, and unfortunately there's no buoys right now to compare exactly the height of the waves, but hopefully in the future, they get to resolve more of this. Following a little bit with that research also is the research that I'm leading in this case, which is towards improving the short-term forecasting for the Lake Victoria Basin. Yeah, I'm leading this project with Tammy Wegbert, also from UL, and then Rita and Jim, that Rita is also here. So I forgot to mention that this data set we have available, it's because there was a prior field campaign called Highway that was led by WMO in the Lake Victoria, funded by the WISER program at the UK. And that's why we have available these data sets, especially the radar data from Tanzania. So what we are doing with this research is to categorize the storms on Lake Victoria in this radar-based analysis. And we have defined the storms that affect Lake Victoria or happen in Lake Victoria in different convective modes. And those convective modes are important to know later, like how the storms are propagated and what is the hazard that might happen on the lake on the surface of the lake. So what we do with this research is then define some guidelines for and conceptual models for Lake Victoria, for the convection in Lake Victoria. And here I'm showing an image of how we divided the Lake Victoria in 4 time slots, and we kind of like identify which convective modes were happening in different time slots and what were the main radar characteristics for those storms. And it's important to mention that these random 4 time slots are not just that we made up them. It's just because we wanted to match the research that we were doing with the forecasting that was taking place there. So from Highway, one of the main things that happened is that the different countries surrounding Lake Victoria put together impact-based forecasting for the fishermen for the lake. And the time slots that they were dividing the forecast was those 4 time slots. So basically, convective life cycle definition based on operational guidance, and we identifying the guidelines for forecasting parameters. We also know more about the Earth system. Well, we have more Earth system understanding, but also important, and I didn't put any slide here, but there's a research to operations also component here, and we've disseminated this work also in trainings with forecasters in Lake Victoria and also through WMO trainings. So moving on, we do have now the East African monsoon as a drawbridge for the circumnavigation of Madden-Julian oscillation events. This is a project led by Samson Hagos from PNNL, who is also here in the audience. So again, if you have any question, please come talk to him at the end of the presentation. And the main message here is basically that the East African monsoon modulates the circumpropagation of MJO, and the MJO propagation across Africa is most likely during the March, April, May, and October, November, December months. So there is a big, important, like global impact of East African precipitation variability that deserve the attention. So the main 3 key points as I mentioned is like the first one, the seasonality, and then during the seasons that they are referred as long rain seasons and short rain season periods, precipitation is near the equator and extends farthest east toward the Indian Ocean. And that seasonal zonal movement of the zonal component of the background circulation regulates the moistening of MJO crossing from Eastern Africa to the Indian Ocean. So we're moving now to the, well, actually the last slide was also from our external collaborators. This one comes from Dale Zhang from the Cooperative Institute for Satellite Earth System Studies, or CISIS. And it's the lining climatology and casualties and impacts work that they are doing in the US and Africa. So they're experts in lining, because lining kills, unfortunately, and also produce injuries and damages all over the world. And Africa is not, Africa is also having a lot of impacts from that. And with advanced technology, we are able to mitigate lining related disasters. So, but also lining is a new essential climate variable that we need to better understand how lining affects climate change and vice versa. Oops, excuse me. So in the US, of course, we have geostationary lining mappers or GLMs. Probably we're all familiar with well, some of us are familiar with that product, satellite product, and have been widely used. So for severe weather nowcasting, forecasting, for airport safety, wildfire early warnings, and etc. And now we're going to have also lining imagery across Europe, but also Africa. So how do we put the efforts that we have right now with GLM also into nowcasting and forecasting for Africa? So also nowadays they are also working in Africa. The mission is for them is to reduce deaths, injuries, and property damage for lining across Africa. And they do have several initiatives and work on the ground. So installing lining protection system at schools, and then also doing public and professional education and research and documentation. And I'm gonna talk a little bit more about this, because the next slide is also related to this one. So related to this previous slide, there's also another slide also from the same group. Marianne Cooper is leading this one and is presenting the African Centers for Lining and Electromagnetics Network, or ACLENET, which missions, again, is to reduce deaths, injury, and property damage for lining across Africa. And I mentioned 3 main points in the previous slide on the actions or work that they were doing on the ground. The one was installing lining protection systems at school that meet international standards. And that is done because school children are the most vulnerable population in Uganda, for instance. It's the one place that they're working on right now. Schools are not properly protected from lining, and children cannot learn if they are too frightened to remain in school. On the other topic, which is the public and professional education, they do public service announcements, monthly newsletter with worldwide distribution in 5 languages. And they also do training of teachers, school district officials, parents, students, engineers, designers, etc. So expanding the network of knowledge, not just for technicians or for researchers. And what is really also important, dispelling harmful traditional beliefs about witches, curses, or sins. So also understanding cultural and environment, right? And finally, for the research and documentation, they have the largest publicly available data set on lining injuries in Africa, which is in the ACLENET website, and I invite you all to check the website. They are doing investigation of school multiple casualties incidents in Uganda, because that is reported at international lining protections meetings. And they also compare of injuries with known patterns to develop effective injury avoidance behavior. So it's also like operations and impact on the ground. The next slide is from Nick van Giessen from TU Delft in the Netherlands. And he's presenting the Trans-African Hydrometeorological Observatory, or TAMO. And TAMO seeks to build and operate a dense network of hydrological and meteorological stations in support of agriculture, early warning systems, and other weather-related services. Most stations are at school, where they contribute to the curriculum through educational materials, and the stations do not have moving parts and have been tested in Africa for more than 10 years. So a lot of data available for that.
Just a reminder of 1 minute.
Okay. Yeah, thank you. Data are available for free for researchers and governments, while for commercial applications, a small fee is required, and also has an excellent team of field staff and engineers who help maintain and build the network. So also important is that they always work closely with national governments, and they have MOUs or memorandums of agreement with most national hydromet services in Africa, sorry, not East Africa. And this is actually my last slide. I think that Sandin, he already presented this group, but this is actually new information too. So this is like from the UCAR COP21 delegation, and they wanted to also transmit a message on what they learned from climate justice and the highlights from that COP21. And this is a work showcased by Sude Kamali and Alexandra Ramos. And the three main issues that were brought up often during the COP21, one was the early warning systems and observational gaps. And in particular, there was a clear message among the international community that there is a need for high resolution observations in Africa, discussing how it hinders progress and how difficult it makes it to provide accurate and useful information to the community. Just an example, in Africa, the number of radio sound observations provided to global models dropped by 50% between 2015 and 2020. The second topic was resource availability. There's a collaboration between the World Health Organization and the nonprofit organization towards working on energizing hospitals and health centers. And as part of an exhibit, they say that they highlighted working conditions in healthcare centers without power and the amount of people globally that are served by facilities with no electricity or limited electricity. So more than 600 million people in sub-Saharan Africa that entices. And finally, the last topic was related to climate and gender equity. And this was a new theme at COP, which was to promote and prioritize production of gender and environmental data in an ethical way. And it had highlighted the disproportionate impact of climate change on women's health and livelihoods. So I just add here the UCAR COP21 delegation. You have all their names and the emails if you want to contact them to know more. And I'm sure that they were more than happy to talk and collaborate with all of us. So that's all, and thank you very much.
Thank you, Anna. I'm happy to invite Abigail Amico from CISL to come and talk about capacity building, education, and outreach.
Okay, hello everybody. My name is Agbili Amiko. I'm with CISL, the Computational Information Systems Lab. We also have Felicity. I'm not sure if she's online. There's Felicity. Hi, Felicity, with the Ghana Meteorological Agency. Okay, I think the speakers are working for her as well, so she may be chiming in on some of the slides so that we can highlight the excellent work that the Ghana Meteorological Agency is doing. Right. Okay, so that's us. And so today we're just going to kind of talk about sort of the education, outreach, and capacity building opportunities. And these are really opportunities to collaborate. These are opportunities to collaborate at a programmatic level, at a research level, and also at a community level. And all of these sort of initiatives that we're talking about is, real actionable items that individuals at a programmatic, community, or research level can actually engage in today. So UCAR, where we are here, is funded by the NSF, and it's a federally funded agency, and UCAR is a sort of corporation of universities. There's 120 or so universities, including minority serving institutions and HBCUs, at least 3 HBCUs right now, maybe 4, that are part of UCAR. Of course, the group I'm in is CISL, which is Derecho, is our new supercomputer that you see there. And there are opportunities for anyone who's doing research to have allocations and access to those supercomputers and data sets as well. And then we also have I'll start with talking about from the highest level, the Office of External Engagement and Business Development. They support through the they support outreach, engagement, and development at the institutional level. They represent offers and single voice to stakeholder communities to find sort of common grounds with the organization. So this is one area of where people who are working with UCAR starts. And of course, this includes conferences. This includes working with engaging and tracking the needs of our community stakeholders. You'll see that there are 3 sort of parts. There's the outreach, there's the engagement, and there's a development part of this organization, especially with the office here. And so we want events like this to actually lead to collaborations, and this is one point of collaboration here in the organization. And you'll see that there's some examples like we talked about earlier. You know, you have AMS conference, COP conference, like you see here. And through this engagement, we're seeing further development opportunities and collaborative opportunities to co-design and build basically collaboration or capacities within the geosciences communities. So we have the Ghana Meteorological Agency. Of course, my family is from Ghana, so we have Felicity here. Felicity, can you hear us?
Yes, I can hear you loud and clear. Hello, everyone.
Yeah, there we go. And Felicity, we have the Ghana Meteorological Society, Meteorological Agency. If you can talk a little bit about the agency there.
Yeah, thanks so much. Yes, Ghana Meteorological Agency was established in 1886 with just three climatological stations, and over time we have evolved, and currently we are having roughly 145 observational networks, and then before we used to be dependent solely on the government, but currently we are also trying to see how best we can rally around to gather some collaborations to help the organizations to bring about the improvements in the weather forecast accuracy. In the near future, we are planning our lesson to go into authority whereby we'll be autonomous and then exist on our own. Over the time, our mission is to provide efficient weather and climate services for socio-economic development in Ghana. We have been mandated by an act, and the mission is to become the lead meteorological service provider in the sub-region. And currently, our staff strength is about 539. And this happened just last year, where we were able to recruit more meteorologists. Before, we have just a handful of meteorologists, which was affecting the accuracy of our weather forecast in terms of the public weather services. Some of the areas that we are venturing into is the marine, which is very new in the Ghana Meteorological Organization, which we need more collaborations to improve it more. We have the aviation industry, which has been there for all these years, but we still need some sort of collaborations to improve. We have the research unit, we have the data unit where we gather all the raw data, the institute data that we have stationed across the country. And now we have the Numerical Weather Prediction Center, which is also new. It's not up to 6 years. It's still underdeveloped, and then we are managing small. Then the public weather services is something also that is new. It came into force with the aviation, but 2018, we have demarcated it, so it's also on its own currently. And it has been a wonderful journey for us, which we are still trying our possible best to see how we can improve all these activities. And the next slide is about the forecast processes, the time scales, and other things that we are doing. We have the weather, the minutes, the hours, the days. And now for us at the public weather service, the days we are doing 3 times daily. It's purely manual, where we have to download the model chart from a different computer, carry it on a flash disk to a different desktop computer, do the manual analysis, and then come up with the forecast, and then also put in 1 or 2 things, which at times also a delay when it comes to now casting, which has to do with the issuing warnings for the public, especially when the storm is approaching. We are now into the subsets now, where we are looking at 2 weeks to 1 month which we started internally. We are yet to bring it out to the public. We are doing the seasonal forecast on the 3 month scale. We are hoping that we will move into climate projection, where we have some collaboration with the BMI, which is helping us to champion that cause. In terms of the public, society, the geographical location that we find ourselves, our weather is not so drastic. It's not so devastating. So at times you get the public not believing in the forecast, so they don't use it. So it is now left to us to educate them and then make sure that they get the forecast and put it into use. So we carry out some outreach programs to educate the communities in the country where we have to do go all the other channels that we have. We are doing Let's Talk Weather on all the available channels that we have, the TV, the radio, the social media handles. So you can check us on which we've been updating day in, day out. We also engage the school children just today, according to WMO that has tasked us to engage the school children. So in the morning session, you realize that I was receiving a lot of visitors. So they were coming in, we were planning the activities for the day, and then tomorrow into next week. So it has been a wonderful journey where we traveled near and far. The pictures on some of the stakeholder engagement that we do have to bring other organizations into one place and educate them about the forecast, the processes that are involved, and also get a feedback from them. And then we also do to the farm, where we also educate the farmers that need this forecast to be able to plan their activities. Those that were numerical weather predictions that has just been established is not too old. We are doing 12 kilometers in terms of resolution and 4 kilometers. We are trying our best to see, and so far it's also doing very well. Currently, we've also introduced the marine modeling into it, that is also running, and it's helping us to give the marine forecast at least to about 5 days ahead of time, so which is helping all of us. So last year we did green climate club, which is not common to our sub-region, where we engage the school children to talk about climate change, talk about climate variability. So last year we engaged them where we formed green climate clubs in 10 schools over the northern sector. This year we are also going to establish over the OT regions, that's the transition area and part of the southern sector. We scheduled it for April into May. So we'll be carrying on. But this one was done last year, where we educate them, and then on monthly basis we do visit them to have interactions with them to broaden their understanding of what they can also do to save the environment. We are also doing the content management system with WMO, where we are trying our best to bring improvements to climate service delivery through the digital transformation to enable our society to better manage the risks and opportunities arising from climate change or climate variability. So it's also new, which is underdeveloped. They are doing their best to see how we can improve it. So from us, this is just what we are trying our best to do to help Ghana, and then to make sure that in terms of weather, in terms of whether there should not be a single life that will be touched, that will be affected. But then we will also need other people to come on board to build our capacity to be able to match up with you guys, so that we can also be able to give what the society is looking up to us. Recently, we have a heat wave, but it's not known to our environment. So you will not even hear it in most of the forecasters that we have here in Ghana. But then if you check the trend, then you know that yes, what is happening currently, guys, I believe most of you have discovered it. January and February temperatures were extremely hot, extremely unbearable for some cases. So these are some of the things that we have tabled, and we want collaboration to be able to come up with the other things to be able to help the Ghanaians populace.
Excellent, thank you. And continuing on the K through 16, we have the GLOBE program here at UCAR that has the International Virtual Science Symposium, and they work with a number of schools in the African region as well. And so you'll see that through the GLOBE program, there is a number of sort of capacity building and curriculum development opportunities, and it's basically just globe.gov, and that's Global Learning and Observation to Benefit the Environment program. And they have an extensive program throughout the Africa region, and they also work on things like setting protocols for understanding not just plant biomes, but also understanding observations of climate. So one of the other things, whoops, did I go? Okay. The other things I want to mention is collaboration here at UCAR. We have a number of postdocs who are from Africa, and summer visitors and other visitors. Some people visit actual labs, or they come in through some of the formal internship programs that do work from Africa and work here at UCAR. So that's something that to look at. There's a large number of opportunities. If anyone wants to know about these opportunities, connect up with me. One in particular is the summer internship in parallel computing. We've had a number of applications. Actually, this year, I believe we had the record number of applications from Africa, or African people from African universities who are international students who attend US universities. We have a number of those students from Africa that are actually coming again this summer. And we also have the SOARS program as well. So there's a number of programs for folks to come here and collaborate. So the ASP is the graduate visitor program. That's another program for graduate students to come and collaborate with UCAR as well. So there is opportunity to be here, whether it be as a student or as a researcher. So now we're going to talk about capacity sharing sort of initiatives. And here we have in Ghana, we have the Climate Atlas, and Felicity can tell us a little bit about that. And I think we have a couple of minutes.
Yes, we have something.
Oh, we have 2 minutes. Yeah.
Yeah, something that we've also introduced last year to come up with the Climate Atlas, which BMI is helping us to do. So last year we signed a cooperation, a memorandum of understanding, where they are helping us to develop that Climate Atlas. It's something new for us. So that is what we are doing currently with the BMI. So they are taking us through with a whole lot of other activities. Then other aspects is also we are collaborating with a common alerting protocol, which was introduced to us by WMO. They are also giving us some little training on how we can report on the severe weather phenomena that normally happen, so that they can get it across. Then we have the weather information dissemination system also in place, but currently it's down, so we'll not be able to get access, but we are trying our best to build it up. We also have my Flood Risk Accra app, which is active, but then we have to feed it manually. The next step is to expand it across the whole country, because this one is just over the Greater Accra region. So it's only those within that catchment area will have access to the alert if any storm that is coming and has a potential of resulting into flood. That's what we do. The other aspect just have to do with the public weather platform that we have using the WhatsApp. It's becoming one of our major channel of disseminating the the forecast that we are generating. So that's what we have to say.
Excellent. And then the last 90 seconds or so, I'm just going to give a couple of highlights. At part of the INCARs, we have a huge data repository. I think there's over 100 petabytes of data, and we're working with communities to understand how to use the data, but also we have allocations of supercomputing allocations, as well as the NSF, the National Science Foundation has supercomputing allocations, and these are open to researchers and collaborators with researchers to use. And these data sets can be used, for, you have to, with communities for tutorials. We have a number of those. And then I wanted to finish up with, we have these 3D printed weather stations. This is a project that I worked on with as well. And this is the 3D pause weather station, right? And then these are 3D printed weather stations that are in over 200 locations, 225 locations. And then we also have another weather station. Let me go, I'll skip it so we can finish this up. We also have another weather station, which is a personal grade weather station that students do as kind of a hackathon. And we've been working with Howard University. You can see the picture in the middle there where they redesigned the weather station to kind of co-design air quality systems and air quality stations to sort of fit the community needs. Now, the last slide, because I think we're about on the last minute, right? The last slide I'll skip to just because we are here with the folks. We do have a affinity group here called the African and African American Affinity Group. It's called A5. And this is one of the many affinity groups here at UCAR INCAR, sort of founded by Warren Washington. You see there in the middle with the bow tie. He's been, I guess he was in INCAR 50 years ago. He's been here for 50 years. He was at INCAR. And he was one of the first Black scientists here, African-American scientists here at INCAR. And the mission is to ensure meaningful stakeholder input from individuals who identify as African and African-Americans in the UCAR INCAR organization and the impact on the community. So this is another avenue for you to connect with the community here at UCAR. And not only do we work with and collaborate with member institutions, but we also collaborate with others, not just the HBCU member institutions, but also African collaborators that would like to collaborate with A5 and the UCAR INCAR community, not just on a scientific level, but also just on the community level to understand how we can work together. And that'll be it. And thank you for listening.
Thank you
you,
so
Tim.
much. So I think that was a great ending from McBilly that opens the door for Andrea Spreen to talk about another affinity group experience and let us know how that came out.
Everybody, thank you for allowing me to speak today. We will stay in the Southern Hemisphere, but we will change continents. And the goal of my presentation here is really to talk about our experience in the South American Affinity Group. I think many of the experiences that we had might be relatable to what you're doing here. Let's see how we advance here. But the spirit of the Affinity Group is really that the total is more than the sum of its pieces. So this is the hope. The basic principle of our research is really that we build on fair, open, and collaborative research. So from the very get-go, when we started our research, we included researchers from South America, but also North America. We have also colleagues from Europe that are participating in basically every planning step, from how we set up experimental designs, what variables we save, how we do the analysis, how we collaborate on the science, and so on. So I think one of the benefits that we had when we started the South American Affinity Group is that we built our modeling expertise on a very long history of expertise at NCAR. So at NCAR, we use convection permitting or kilometer scale modeling quite heavily in South America. We'll come back to this in a second. And we started doing this kind of modeling with the weather research and forecasting modeling system more than a decade ago over actually Colorado headwater. And then we expanded our capabilities to continental scales over North America, focused on the contiguous United States. with increasing computational power. And every step that we took here, we tried to improve the modeling system along the way. So you can see the physics changed over time. We included additional components. For example, groundwater representation in the model was a really important inclusion from CONUS 1 to this CONUS 2 data set. The most recent one, we basically just finished CONUS 4.4, and we took all this expertise to run very similar simulations over South America. And this is basically what I'm showing you here. What we have over South America is two 22-year-long simulations, a current climate and the future climate simulation at 4 kilometers that really show you underrepresented insights on very small scale phenomena in the region. The talk here is not really focused on the science or the modeling, it's really focused more on the experience. But I think here we really largely benefited from the experience that we already had at NCAR with building these modeling systems and transferring it to a different region. So what you see here is a timeline of how we grew over time. The South American Affinity Group was actually initialized in an NCAR water system program retreat, where we decided that we want to expand our modeling capabilities to South America from North America. And we started to meet, or basically create an email list in 2019. And this is basically what the start point here is. And you can see we grew gradually quite large. We are now about 170 scientists, very international. Most of those are actually from South America, and we're still growing. This is really more word of mouth nowadays, where just people talk about what we're doing and we invite additional people to what we're doing. And I think this works pretty well. For me, having this gradual growth was really a good thing, because we started with a smaller group, and I think everybody was familiar with each other. And if you join our group meetings, I think it's a very intimate discussion that we often have, because many people know each other for a long time. And if we add new people, they get integrated in their group that's knows each other for quite a long time period. What you see here as well is like just the institutes. I think this is not a complete list. I compiled those a couple of years ago, probably many additional institutes now, but it's a very broad group of researchers that we include here. So when we started, I think it was really important for us to know exactly why we want to do this, why we want to focus our research on South America. So sorry, wrong continent. And we basically focused on the urgent needs to improve the understanding how climate change impacts hydroclimate in South America, because it's really an understudied continent similar to Africa. So the why was always very important. Then we said, how do we want to do this? I already talked about this a little bit at the beginning. It was really by performing community-based science with the spirit that the whole is more than the sum of its pieces, that we really try to collaborate as much as possible and benefit from each other's expertise. And then really what we are doing is basically we use novel kilometer scale modeling systems to generate weather forecast scale information on climate timescales over South America. And I think the direction of this was really important to start with the why, because often I think it's the opposite. You know exactly what you do, but you don't know exactly why you do it. So this really helped us to keep focus and to build an effort that's serving the whole community. So these are the modeling systems that we are using. The flagship system, where we definitely spend most time in, is the weather research and forecasting system. The domain is shown on the left. The colored domain is the South American domain. You can see the other domains that we are running as well. The South American domain is actually by far the biggest one that we ran so far. We also have the system for integrated modeling of the atmosphere, CIMA. In this is basically a configuration of the CESM2 model going down to very high resolution. It's a global model, but with a regional refined mesh over South America, going down to 3 kilometers, so we can compare the WRF simulation to this global simulations. And additionally, we also have simulations from the UK Met Office with the unified model. So we also have an abilities to look across scales across the modeling systems and learn how different modeling systems are simulating climate and climate change over South America. So I wanted to take a little bit of time to talk about the remaining challenges or main challenges that we face within our community, and also some lessons learned. Starting with the challenges. One of the big challenges, I guess you will probably run into the same issue. Sharing data is really, really difficult. Like we produced approximately 2 petabytes of data with the WRF simulations alone. And even though like we provided the computational resources and carried out the simulation and shared the data openly on the Research Data Archive, we heard about this already. It's still very difficult for many of our colleagues in South America to download the data, to store the data locally, and to analyze the data. So there's definitely still a bottleneck. I will talk about major improvements in this area in a second, but this is something I think at NCAR that we don't do extremely well at the moment, to really allow people to interact with the data at the location of the data. Computational resources, it's a different topic, but also technological. So even if our colleagues are able to download the data, just analyzing petabytes of data is really, really difficult. It's actually even difficult if you're at NCAR with pretty good computer systems. That's a big bottleneck as well. And opening up the data, again, like it's a similar problem. Opening up the data to the community would be really beneficial. And I think, like, again, like advances in our affinity group would probably be able to translate into your affinity group at the Africa work that we do at NCAR. The model validation, as particular in the Andes, we already heard about observational capabilities and how like limited they are often in the Southern Hemisphere. South America is not different here. And especially if you go into mountain regions, observational capabilities are really poor, and it's extremely hard to evaluate the model in this region. It's really difficult to say if the model is right or the observations are right. It's even hard in North America, but it's much more difficult in the Andes. And then sampling of future climate uncertainty. So these simulations are extremely costly to run. We only were able to run one simulation into the future. It's one deterministic run, and it's really difficult to say how representative is it for future climate in South America, specifically if you want to translate our simulation in decision making. So again, having an international collaboration, for example, with the Met Office, which provides at least a second assessment of how climate is changing, was really beneficial here. But again, it's a community effort. The more people you can bring into this community, and the more you can coordinate on these kind of simulations that they get into comparable, the better. So some lessons learned. Community-based research takes time. I guess you probably experienced this as well. This affinity group is now 5 years old, and we really grew over time. And it takes a while to really gain trust, to establish protocols, and to basically just learn about each other and work together. And we're still improving in this area. Together we can go further and we can achieve more. I have a list of major achievements that I think that wouldn't have been possible without including partners from South America and other regions on the next slide. Regular engagements are really key. Like this, we really try to engage every second week. I will talk about this a little bit more, and have in-person workshops as well. So you have to really connect with the people on a regular basis, which again takes a lot of time. Which brings me to the last point. It really needs a long-term investment in coordinating these activities. This is nothing you can do with a one-term investment for a year. You really have to put effort into this over many, many years, continue the work. And like often the gains are really, the payout is coming later on, but you really have to invest a lot in the beginning. And you need a strong leadership team. So you really need people that are engaged, that are motivated, and that also have the resources to lead and to coordinate. So talking about the regular engagements, we have bi-weekly meetings. Those are purely virtual. So it's really everybody is in the same. So people at NCAR don't have a benefit just because they sit in neighboring offices. And these bi-weekly meetings are really key to keep engaged, to stay up to date, who's doing what in the community, and also to plan experiments that we want to run into the future. We have working groups. One of them is, I think, fairly active, which is the Convection and Extreme Precipitation Working Group. So we try to And what we did initially is we tried to find out from the community which research interests do you have, and then we tried to cluster those research interests into working groups. And again, like this really takes leadership. So you need people that are eager to lead these working groups and to coordinate the research in these working groups. And some of those working groups are a little bit struggling with that. Others are pretty successful. So we just, for example, are about to publish a paper that we wrote jointly in this convection permitting, or convection deep extreme precipitation working group. And we also use, of course, the web to coordinate. We record all the meetings, we upload the recordings. We have a lot of documentation on our website. For example, how you access the data, contact details, observational data sets, a collection of observational data sets that you can use, and so on. And we have organization of in-person workshops. And I will show you this on the next slide. We, for example, had a workshop in Buenos Aires, which was really helpful. We started this affinity group in 2019, and we all know what happened in 2020. So we were not able to meet at all. And this was the first time we really could get together and meet in person. And this makes a difference in my experience. Like if you know people, you met with them in person, the relationship is often deepened, and the work together is really stronger afterwards. And we do this annually now. So we, for example, we had a workshop in Bergen last year, and we brought in a couple of collaborators. We had funding to bring in a couple of collaborators from South America, and we did a nice hike in Bergen and had beautiful weather, which is quite extreme in this region of the world. So I wanted to end with major community achievements. So this is coming back to this 1+1 is 3. These are things that we couldn't have done alone at NCAR. So first of all, data sharing. We produced 2 petabytes of model data. And actually, we didn't have space to save all of this at NCAR disk. So we had people from the community chime in, the University of Illinois and DOE specifically, they saved backups of the whole data sets on their archives, and they share the data set through Globus with the community. Additionally, the water system program at NCAR is sponsoring the research data archive sharing of the data. It's quite a major cost item. This is not free to share, but basically everybody now who has internet access, in theory, can access the data set. Of course, I talked about the limitations that we still have in these regions a little bit earlier. Observations, collecting observations in South America is really difficult. Our South American colleagues were really doing an excellent job. People from different continents, they contact their own MET services and got an amazing amount of in situ observations. It's really astonishing to me how many stations there are, because if you look at global data sets, there are almost none. But if you talk to the right people at the right place, often it's also a language barrier, you can get much more data. Like one of our colleagues basically said, you really have to know the right person to get the data. And this is really true. And again, this takes a community effort and local expertise and connections locally to achieve that. Data sharing, the computer center in Chile, who is hosted in the University of Santiago, recently agreed to share all 2 petabytes of our model output on their computing system. And they also agreed to give everybody globally access to compute and the data. So this is a major milestone. So we're about to transfer at the moment the data sets, the complete data set to South America, so they have their own storage, their own copy of the data, and have their own compute next to the data, which is really, I think, a milestone to move forward to do open science. And we will see how this works out, but I'm really excited about that. And I'm very grateful to the Chilean Supercomputing Center that they agreed to do this, because this is not cheap. And last but not least, we collaborated with computer visualization artists to create 3D renders of our model output, of the WRF model output. And those are really, I think, really beautiful, emotionally moving. I will show you the video in a second. And I think it's a great way to do outreach with the data we have to the general public, but also to inspire other researchers to get involved. So I will show you, the video takes approximately 3 minutes. It has some sound. I will show you the video, and I think this is the last slide that I have, and probably we can move into open discussion afterwards.
Exactly. And while you are putting the video on, we can have all of the speakers to come and settle, so we have the Q&A right after.
I hope this should start with a click. Oh yeah.
South America's hydroclimate sustains vibrant communities and natural ecosystems of extraordinary biodiversity, including the Andes Cordillera, the fertile plains of the La Plata Basin, the Pantanal, which is the world's largest tropical wetland, and of course, the Amazon forest. Global warming and land use change are endangering ecosystem health, exacerbating hydrometeorological extremes, and threatening water and food security for millions of people on the continent. The South America Affinity Group, or SAG, was established as a community effort focused on improving hydroclimate science over the continent. At the core of the SAG effort are 2 climate simulations that represent historical and future climate with unprecedented detail. Our goal is to support better informed decision-making. We will present model results for winds, moisture fluxes, clouds, and precipitation over the continent. In northern South America, tropical low-level winds from the east traverse the Amazon and veer south, forming the South American low-level jet. In the south, intense winds from the west form large systems. These winds carry moisture. Most of the moisture is from the tropical latitudes and is transported south with the low-level jet. You are about to see model simulations of clouds and precipitation at unprecedented resolution. Taking a closer look at the Amazon, we see a clear diurnal cycle of convection. We also see how clouds organize over the Andes and some larger convective systems that form. If we remove the clouds, we can see the precipitation. Rain is very frequent over the mountains and over the Amazon basin. Moving to the southern mid-latitudes, we see an atmospheric river from the Pacific that encounters the Andes Mountain. We also see convection initiating on the eastern side of the Andes to form a large traveling mesoscale convective system, or MCS. The atmospheric river brings rain to the Andes, while the MCS rains over the La Plata Basin.
Excellent. Thank you so much, Andres, for sharing it. I think it was very refreshing, and I hope that helped to articulate your questions. So